Hi, this is John Schmidt, and I want to talk to you this week about the time value of money. This is one of those subjects that so many people really when you start to talk about it, sometimes people become like a deer in headlights. Their eyes start to glaze over and they just don't really understand everything that you're talking about. So I want to remove some of that mystique today by just kind of giving you an overview of what you're going to find in your textbook in chapter 3. When we talked about the time value of money, there's all sorts of formulas that get thrown around. And when you see these formulas put in algebraic form, a lot of times it can become very confusing. But I kind of want to break it down so that if you understand conceptually what we are trying to accomplish, then you can kind of work through the formulas a little bit easier. There's really two kinds of formulas that we're going to be looking at. The first one is when there is a one-time payment involved. For example, you receive a payment that you sit here and say, okay, what is the future value of that payment? What is it going to be worth if I receive $1,000 right now? What's it going to be worth at some point in time in the future? And you make certain interest rate assumptions, you make certain number of periods assumptions, and you take whatever that dollar value is and you multiply it by a factor. And the factor that I'm going to walk you through is the factors that are in the tables in the textbook. But I'll come back to that. The second kind of payment is you're going to receive some sort of payment in the future, and you want to know what that payment is worth today. And there's a formula for that, the present value, which is the future value times a factor. And again, I'm going to walk you through this, but if you understand that it's a payment that you either receive today and you're trying to figure out how much it's going to be worth in the future, or it's a payment that you're going to receive in the future and you're trying to figure out what it's worth today, that's one category. The second category is when there are annual payments involved. And this is whether it's retirement payments, lottery winnings, payments that you're paying on loans, whatever it may be. And in this scenario, there's really two different kinds of payments. One of them is really saying, okay, I'm going to get a number of dollars per year for X number of years in the future. And what am I going to actually have in the future when I get those number of dollars? And you're going to make certain assumptions with respect to interest rates and number of periods. And again, it's looking at it the other way around, which is I'm going to receive these payments in the future. What is that really worth today? And backing into that. So just understanding that these two basic categories of a one-time payment, and you're looking both ways on a one-time payment, and you're looking at annual payments and you're trying to figure out what those are going to be worth, then that will help you on the time value of money. So I want to walk you through some specific examples, and we're going to take a little field trip to our Helena studio for me to walk you through this. We're in the Helena College studios right now, and I want to talk you through just conceptually this whole concept of the time value of money. Because all of those equations, those algebraic equations that I showed you on the previous slide, for some people, they just you start to see those things flying around and they just kind of freak out. They go, I don't understand, and they immediately shut down. So, but if you understand the time value of money from a conceptual standpoint, then it's a whole lot easier to go back and in essence, plug in numbers to do the kind of calculations for whatever solution that you are being asked to come up with. So I want to just go from a very simple basis of saying, let's say that you put $1,000 in the bank on January 1st. And for that $1,000, you're going to earn 3% on that money. And you sit here and say, okay, I want to know how much am I going to have in my savings account at the end of 3 years? Very simple. Well, you could take the longhand approach and say, okay, I'm going to take $1,000 and I'm going to multiply it by 1.03 to find out what I'll have at the end of year number 1. That's going to be $1,030. And then I do that again for year number 2, and I'm going to have $1,061. And then at the beginning of year number 2, I'm going to earn interest that at the end of year number 3, I'm going to have $1,093 in the bank. Now that's very simple, and you can cheat and come up with the answer that way.
or you can use the tables that are provided and this formula up here. This formula up here is referring to, and the PV is the amount of money that you have currently, the present amount of money. You're going to take that, you're going to multiply it by some sort of factor that's going to be provided to you. That factor is going to, you have to make two assumptions. One of them is what your interest rate is going to be, and the second one is the number of periods that you're going to be calculating for. So interest rate of 3%, we set for 3 years, and that's going to give you, in essence, your answer as to how much money you're going to have 3 years from now. So if you turn in your book to Appendix C, Table C.1, you will see there that it has the table there that has already calculated out that factor for you, that fair value factor, interest factor. And so you look there in the column that says 3%, you go down to the third line for 3 periods, and you see there that there is a number called 1.093. So what you're going to do, again, using this formula, is you're going to take your $1,000 that you're putting in the bank, you're going to use from that table 1.093, and voila, what do you have? The same answer. Now you can do this on a financial calculator. There's instructions in the book as to how to use a financial calculator if you go that, or you can go manually to the table itself. Let's look at scenario number 2. Again, this is the same basic scenario. Scenario number 1 is we receive $1,000 at the beginning of year 3, and we want to know what it's going to be after 3 years. Scenario number 2 is we're going to be looking at and saying we have a certain amount of money we want to have at the end of year 3. What do we need to put in the bank today to ensure that we have that amount of money? So let's just use the same example that we're talking about here, that we want to have at the end of year 3 $1,093. How much money do we need to put in the bank today at 3% per year to get to that? Well, we've already done the calculation, but sometimes you don't have this kind of information. You need to be able to back into it. So this algebraic formula is basically switched around, and it's got a different factor that we're going to be using. So we're going to go to table C.2 in the back of the book in Appendix C, and we're going to see under the 3% column and the 3-year row, we're going to see a factor there of 0.915. So we're going to take the fact that we want to have $1,093 at the end of 3 years. We're going to multiply that by 0.915, and guess what the answer comes up to? $1,000. It's relatively straightforward. It's pretty simple. And I know I'm talking about just simplicity here, but if you are able to understand conceptually, no matter what scenario is put out before you, if there's a one-time payment that you're either going to be receiving now or receiving at some point in time in the future, these are the calculations that you use. Now, we just looked at scenario number 1, which is one-time payment either at the beginning of a period or at the end of a period. But sometimes we receive payments periodically. Let's say we win the lottery and we get $1,000 a year, and we want to know how much that $1,000 a year is going to be worth at the end of 3 years. Or we have a retirement payment, or we have something that's some sort of annuity type payment is. We want to know what the value of that is going to be in the future. And so in table C.3, we again are given the same kind of factor to be able to back into that. So you need to make certain assumptions. Again, the assumptions are interest rate assumptions and period assumptions, and we're going to stay with our $1,000 right now and use that. So we're going to assume that we're getting $1,000 a year every year at the beginning of the year, and that we're going to get that for 3 years at 3% interest. So the question is, what are we going to have at the end of 3 years? So we're going to take our formula here, which is the payment, times table C.3, and it's going to give us a different factor in there, and that factor is going to be, if you look in there, is 3.091. 3% column, 3% year, and that means at the end of 3 years we're going to have $3,091 if we get $1,000 a year at the beginning of the year. Now if we get it at the end of the year, we have to calculate differently, right? Because we don't receive interest on that until the following year. So this amount, this works if we receive it on January 1st. But if we receive this money on December 31st, really, and we want to know what we're going to have on December 31st, 2 years later, which is the end of the third year, we have to use a different factor. We have to use the factor for 2 periods rather than 1 period. But let's kind of take this scenario here and change the assumptions a little bit. Let's change the assumptions from 3 years and say now we're going to receive this $1,000 a year for 20 years. We really did win the lottery. How much money am I going to have at the end of 20 years? So we take our $1,000, again, using the same assumption of 3%, and going down to the line that says, the row that says 20, we see there that the factor is 26.870, which means at the end of 20 years, we're going to have this much money in the bank, assuming a 3% return on our money. Now, the question comes down to, what happens if somebody comes to us? And you will see this sometimes, that people will come and say, hey, you won the lottery. You're going to get $1,000 a year, but we want to buy you out of that annuity payment that you're going to get. And we are willing to give you $18,000 for that, for the right to that. Now, at first blush, you said, wait a minute, $18,000 for $26,000 that I'm going to be receiving in total? That doesn't sound right. But you need to take into account the time value of money to figure out if that is a really good deal. So I want to show you, and again, this is why it's important to understand this conceptually. I want to show you 2 different ways of looking at how to solve that particular kind of problem that we're talking about. The first way is based upon what we've already talked about, because when you go through here and you say, okay, I'm going to receive $1,000 a year for 20 years, what is that money going to be worth? How much money am I going to have in the bank 20 years from now? We've already got that answer, right? We've got $26,870 that's already going to be in the bank. So we sit here and say, okay, well, that $26,870 I'm going to have 20 years from now, what is that worth today? Well, we looked at on the previous, the one-time payment is, we can take a value of something that we're going to be receiving in the future, and we can back that up, present value, to see what it's worth today. And so we can take this $26,000, $26,870, and we can go to table C.2, which again looks at something that we're going to be receiving in the future, and we take the factor of 3% for 20 years, and we see there that the number is 0.554. And if we multiply 26,870 times 0.554, that the value of that, and I cannot write, it's 885. The value of that money today is $14,885. That's what it's worth, this $1,000 for us. So you can see here that with the equations that we already have, we can back into a solution here. Now, it's a 2-step solution because we have to determine what the fair value is in the future, and then we have to back it up to today using a present value, using 2 different calculations. Well, that algebraic and those numbers have actually been figured out for us ahead of time. So we can go to table C.4 to kind of do a little bit of a shortcut on this. And what this does is this says, okay, I'm going to take my payment of $1,000 a month that I'm going to be receiving. I can take the factor that's in the table, C.4, on page 632, and the factor that is out there is 14.878. And this $1,000 that I'm going to receive over the next 20 years, what it's worth to me today is $14,878. Now, the little bit of difference here is because the tables don't take it to the most significant digits, so you have a little bit of rounding error. If you use a financial calculator, it'll come up with the exact same answer. So the question is, if somebody comes to me and says, I'll give you $18,000 for your lottery winnings that you're going to be getting, you go, yeah, I'll take the offer. If it's less than this amount, you're probably going to reject the offer outright. Hopefully this gives you a little bit of insight as to just how to approach the time value of money, so that when you start to look at problems, real life problems, when you look at word problems, you can kind of figure out, okay, what are the component pieces that they're really looking for, and how can I break it down into these kinds of relatively simple equations to understand. Thank you.